The universe is everything that exists. Space, time, matter, energy, and the very vast cosmic web that connects them all and is still expanding with the speed of light. Starting with the Big Bang, it went through different phases including inflation era, formation of fundamental particles, cosmic microwave background, dark ages, formation of stars and galaxies, reionization, formation of our solar system and present-day universe, and continues to expand with the uncertain future depending upon the nature of dark energy. It might fall in itself a process known as Big Crunch. As per the Big Bang Theory, the leading explanation of how the universe began, around 13.8 billion years ago, the universe started with a bang from a point known as singularity, with infinite temperature and density. However, nature of singularity is beyond our understanding as laws of physics break down under such condition. It was not an explosion, rather, a rapid expansion of space itself, marking the beginning of everything including time, space, energy, and matter. Soon after the Big Bang, all four fundamental forces came into existence, including electromagnetism, that governs interaction between particles, gravity, that governs large-scale structure and motion in universe, strong nuclear force, that holds atomic nuclei together, enabling atomic formation, and weak nuclear force, that facilitates nuclear fusions. In inflation era, universe expanded dramatically in a fraction of a second, right after the Big Bang, and solved the flatness and horizon problem, laying the foundation for the large-scale structure and formation of universe. Roughly after 3 minutes, universe rapidly cooled down from its initial hot and dense state. Formation of fundamental particles took place, including gluons, quarks, electrons, protons, and atomic nuclei, and universe primarily was consisted of hydrogen 75%, helium 25% with traces of lithium. 380,000 years after the Big Bang, after the formation of electrons, atomic nuclei, and neutral atom, photons were able to travel freely. That gave us the faint glow of the early universe, the radiation, known as cosmic microwave background. Between 380,000 to 150 million years, the universe went through dark ages with no star or galaxy and cooled down gradually, allowed gravity to clump together the low-density matter, to start the formation of early stars and galaxies, helped by the crucial role played by dark matter. 150 million years after the Big Bang, after a series of events, including inflation, formation of fundamental forces and atomic particles, first star in the universe finally ignited, ending the phase of dark age of universe. Early stars were massive and quickly used their fuel. These stars formed together under the influence of gravity and dark energy and matter to form the very first galaxy of the universe. After the formation of early stars and galaxies, reionization era began that took place between 500 million to 1 billion years after the Big Bang. The ultraviolet radiations and high-energy photons from the early massive stars and galaxies ripped off electrons from the neutral hydrogen atoms that turned dark and opaque universe into transparent universe, allowing photons to travel freely in the universe and turned the dark universe into light-filled cosmos state as we see today. Our solar system formed around 4.6 billion years ago from the cosmic clouds. When our sun reached critical temperature, it ignited fusion reaction that blew away the cosmic dust through solar winds, leaving behind the planets revolving around it. Our Earth formed 4.5 billion years ago and became suitable for life around 3.8 billion years ago. Around 3.5 billion years ago, cyanobacteria came into existence that started photosynthesizing and released oxygen, the fundamental element for life as a byproduct, laying the foundation for the later complex life. In present day, as per our limited knowledge of observable universe, there are two types of matter, baryonic matter and non-baryonic matter. Baryonic matter includes all the matter that we can see and observe, and non-baryonic matter is the matter that we still don't know about. As per a rough estimation, there are billions of galaxies, ranging from 200 billion to 2 trillion galaxies, each with stars ranging from 100 to 200 billions, and each galaxy has supermassive black hole at the center, with billions of stars swirling around it. Other baryonic matter includes nebulas and cosmic dust, the building material of stars. Where stars are born, each star has planets revolving around them, some with moons, and also the asteroids and comets known as remnants of planets and moons. Then comes the most fascinating phenomenon of universe, known as black holes, that are neither considered baryonic or non-baryonic, forms from the collapse of megastars, and has gravity so intense at the center known as point of singularity that the laws of physics as we know them break down there, and even the light cannot escape from there. And when the star comes nearby the black hole, then there is no point of return, known as even horizon. They pulls out material of star and form a disk, called accretion disk. All this matter, including galaxies, stars, black holes, pulsars, neutron stars, planets, moons, nebulas, cosmic dusts, asteroids, and comets, amounts only 5% of universe. Whereas there is 95% of the universe, which we have no idea about, that include the mysterious and dominant force in the universe, known as dark energy, that accounts for about the 68% of the total universe. It is hypothesized to be responsible for the accelerated expansion of the universe. Other prominent theory about dark energy is that dark energy is the property of space itself. Some scientists suggested the theory of vacuum energy. That is, the empty space is not actually empty, but rather filled with virtual particles. Dark energy remains the biggest mystery of universe, as it doesn't interact with matter. Whereas dark matter, that amount up to 27% of the total mass and energy of the universe, but it is also a mysterious subject, as it doesn't emit, absorb, or reflect light, and is only detectable through its gravitational effects, and is believed to hold down the galaxies and clusters together. It plays a crucial role in formation of galaxies, but it remains the biggest puzzle in our understanding about the cosmology. There are 3 ways the universe could end that are Big Rip, Big Freeze, and Big Crunch. As per the Big Rip theory, the dark energy or repulsive force will win over gravitational force, as these two forces are in fight with each other constantly. Gravitational force holds while repulsive force pull out each other. If the expansion of the universe continues at an accelerated rate, then eventually it will overcome gravitational force, and galaxies, clusters, and solar systems and universe will tear apart from each other. Also, repulsive force will not only overcome gravitational force, but also the electromagnetism and strong and weak nuclear forces that holds together the atomic structure. This would result in tearing apart not only galaxies, clusters, and solar system, but also the atomic particles, resulting in a process known as Big Rip theory. As per Big Freeze theory, also known as heat death, the dark energy wins over gravity, but unlike Big Rip, the expansion will not accelerate rapidly, but universe keep getting bigger and bigger. Matter, including clusters of galaxies, stars, and planets, keep moving away from each other until galaxies dissolves and everything fades away. In third scenario, the Big Crunch theory, in which gravity wins over the repulsive force. In this, the gravity will halt the expansion and then reverses it. As the galaxies rushes towards each other, the gravitational pull will get even more and more stronger. Stars, planets, black hole, and every matter will collide, and space will get tighter and tighter, and size of universe will plummet until everything, even atoms and electrons, will crunch together to a point of infinitely hot and dense point singularity. Another related theory to this is known as Big Bounce, according to which this can be another cycle for another Big Bang, another repetition process of universe, repeating its entire history again. But our understanding of universe is very limited. There is also a theory that there could be multiple universes with different physical laws. So our understanding of the vastness and complexity of universe is far from over.